An unseen force moves far below the Atlantic Ocean's surface. It controls the oceans, the climate, and even the destiny of billions of lives. But you cannot see it or touch it. The massive conveyor belt that transports warm water north, cold water south, and carbon deep into the seas is known as the Atlantic Meridional Overturning Circulation, or AMOC. However, it's slowing down now. Additionally, some experts caution that it might completely collapse possibly throughout our lifetime. You might be surprised by how close that world is. In this video, we'll delve deeply into the AMOC, how it functions, why it matters, and what can happen if it fails. My name is James Stewart. Get ready for what's beneath the Atlantic is more terrifying and powerful than you could have ever imagined. Number 10. Why the AMOC matters. To understand why, imagine the Earth as a living organism. The AMOC is its heartbeat. It drives warm tropical waters north, keeping Europe temperate. At the same time, cold, salty water sinks in the north, carrying heat and carbon back south in a deep ocean loop. The heat it transports, about 50 times the energy humanity consumes globally. In other words, it's like a million power plants running simultaneously, silently, beneath the ocean surface. Without the AMOC, Europe could experience winters 10 degrees Celsius colder. The tropics would overheat, storms would intensify, crop failures would become widespread, and the oceans, unable to store carbon effectively, would accelerate global warming. This invisible system is, in many ways, the foundation of life on Earth. It moves more energy than humanity consumes silently every second, and we barely notice it. Number 9. Signs the AMOC is slowing. For decades, scientists have noticed a strange anomaly, a cold blob in the North Atlantic. While the rest of the planet warms, this region has actually cooled slightly over the last 20 years. The cause? Greenland's ice sheet is melting at an unprecedented rate, releasing over 270 billion tons of fresh water per year. Saltier water is dense, it sinks and drives the AMOC, and it's a feedback loop. The slower the AMOC moves, the more fresh water stays at the surface, further weakening the current. Imagine your home's central heating. If the pump slows, rooms freeze while others overheat. Now imagine that on a planetary scale, that's what's happening in the Atlantic. Greenland ice melting, fresh water spreading into the North Atlantic, ocean density gradient animation. Number 8. How the AMOC works. To truly grasp the danger, we need to understand the AMOC's mechanics. It's part of the larger thermohaline circulation, thermo meaning temperature, haline meaning saltiness. Warm water travels north, cooling as it goes, and becomes denser due to salinity left behind by forming sea ice. This dense water sinks deep into the Atlantic and travels south along the ocean floor. Eventually, it rises near the tropics, warming again and completing a gigantic loop. It's a cycle that takes about 1,000 years for a single parcel of water to make the journey. Along the way, it delivers nutrients that fuel marine life, transfers heat that stabilizes climate patterns, and sequesters carbon from the atmosphere. It's one of the most critical systems regulating our planet, yet it remains largely invisible and underappreciated. 3D animation of water cycling from tropics to Arctic and back, showing heat, salinity, and carbon flows. Number 7. Lessons from history. The AMOC has collapsed before, and when it does, the results are dramatic. During the last ice age, it failed multiple times, triggering abrupt climate events called Dansgaard-Oeschger events. Temperatures in the northern hemisphere spiked or plunged by 8 to 10 degrees Celsius within decades. Europe plunged into near-glacial conditions. The tropics sweltered and storms became extreme. Ecosystems collapsed, sea levels fluctuated, and the climate became unpredictable. This isn't science fiction. These events are recorded in ice cores and seafloor sediments, and they show that the AMOC is inherently unstable and highly sensitive to changes in salinity and temperature. Timeline of Ice Age events: animated iceberg surges, temperature spikes. Number 6. Potential impacts today. What would a collapse look like in today's world? Europe could see temperatures drop by 3 to 10 degrees Celsius. Cities like London and Paris might experience winters like northern Canada. Storms would intensify, with some regions facing unprecedented hurricane-like winds and flooding. Agriculture would be devastated. Crops like wheat and potatoes could fail consistently, creating food shortages in a world dependent on stable climate patterns. The Amazon rainforest could experience seasonal chaos, with wet seasons turning dry and vice versa, threatening countless species and disrupting a vital carbon sink. And the oceans, they would absorb less CO2, leaving more carbon in the atmosphere, accelerating global warming and creating a dangerous feedback loop. Animated maps showing temperature anomalies, floods, droughts, and Amazon rainfall shifts. Number 5. The Amazon and global climate. The Amazon is often called the lungs of the Earth, absorbing massive amounts of carbon and regulating global climate. A weakening AMOC would destabilize rainfall patterns there, altering dry and wet seasons. Even small shifts could have massive ecological consequences. Trees stressed by unusual dry periods would die, biodiversity would collapse, and carbon sequestration would drop. In a way, a slowing AMOC doesn't just affect Europe and the North Atlantic, it sends shockwaves across the entire planet. A single ocean current could disrupt the lungs of the Earth itself. Number 4. How scientists track the AMOC. Despite its importance, the AMOC is notoriously hard to measure. Satellites can't see it. To monitor it, scientists deploy deep ocean instruments called moorings. These devices, suspended thousands of meters below the surface, measure temperature, salinity, and current speed. Programs like RAPID and OSNAP track the Atlantic in real time. One key warning sign is a drop in deep water formation. If northern waters stop sinking, it signals the AMOC is approaching a tipping point. The data shows early signs of slowdown, but there's not yet enough evidence to pinpoint exactly when a collapse might occur. Number 4. Can the AMOC recover? Historically, the AMOC has rebounded, but recovery took centuries. Today, with CO2 levels higher than any point in 15 million years, recovery could be slower or impossible without drastic action. Some models suggest a resilience window of 20 to 50 years. If freshwater input slows quickly, the AMOC could stabilize. Delay, however, and the collapse may become permanent. Humanity has never faced such a delicate balance, where centuries of climate history are determined by decades of human activity. Number 3. The science behind the slowdown. Why is this happening now? Several factors converge. 1. Record high greenhouse gas emissions. 2. Arctic amplification accelerating ice melts. 3. Altered evaporation and precipitation patterns changing salinity. 4. Massive freshwater input from Greenland melting. This creates a dangerous feedback loop. Slower AMOC to less salty water reaching the north, to weaker sinking to even slower AMOC. Scientists call this salt advection feedback. In simple terms, the current feeds itself and disrupts it, and the entire system spirals downward. Number 2. Conflicting predictions. When will the AMOC collapse? Scientists disagree. Some studies suggest the tipping point is around the 2050s. Others warn it could happen sooner or later, depending on emissions, ice melt, and oceanic shifts. Climate models are tricky. The IPCC uses hundreds of models, but critics argue they are too stable, underestimating risk. Other methods, like using sea surface temperatures as a proxy, are debated. But all researchers agree unchecked global warming makes slowdown inevitable. It's no longer a question of if, but when. Number 1. What can we do? The solution is simple in theory: drastically slow global warming, reduce greenhouse gas emissions, protect ice sheets, and safeguard oceans. We often focus on visible climate effects, droughts, floods, heat waves, but hidden systems like the AMOC are just as crucial. Collapse could happen silently, yet devastate life across the planet. Protecting these hidden forces isn't optional, it's survival. The AMOC is a reminder of how fragile and incredible our planet truly is. Hidden forces like this shape every aspect of life on Earth, and understanding them is the first step to protecting our future. If you found this journey beneath the Atlantic eye-opening, hit that like button and make sure you subscribe to Astrum Earth for more deep dives into the forces that shape our world. We leave no stone unturned, no current unexplored, and no mystery unsolved. Join us and see the Earth in a way you've never seen before. Thanks for watching, and we'll see you in the next adventure.